Hello and welcome. In today's video, we're going to do something a little different. What we're going to do today is solve a common network automation problem, and that is trying to find out all the public IP address ranges for a SaaS service. We often need to do this for numerous reasons. One of the core reasons is we need to write potentially firewall rules based on only allowing a certain SaaS provider's public IP ranges through a firewall. So what we're going to do today is we're going to prove how we can build a solution from start to finish using the AWS public IP address ranges. So before we get into the coding, let's just quickly talk about the actual problem. So the problem that we need to solve is to get a list of all public IP address ranges for a cloud service so that those explicit ranges can be added to your firewall policy. What we're going to do today is work through the solution, and the first part of that is to document out the workflow. So before we actually write any code, it's a really good habit to get into to write out the workflow of how you plan to achieve the solution. This will help save you time in the long run and will help you organize your code in a more legible manner and help you work through the problem in a piece, taking a piece by piece approach. All right, so first, let's just write out a workflow of how we plan to solve this solution. So if we needed to parse the IP addresses of a SaaS provider, the first thing we need to do is work out where the AWS public ranges are situated. All right, and we need to find the URL if there is one. Next step would be we want the URL to query. We want the URL so we can query it programmatically. Okay, once we have the URL, obviously the next step would be to retrieve the URL. Okay, and we probably want to report the success or failure. Obviously, if it fails, we don't want to do anything past that point. There could be numerous reasons why a URL could fail. It could be a proxy that you're using inside your environment. It could be someone, made a fat finger typo on the script. The service could actually be unavailable. So we want to know whether the URL retrieval was successful or not before we go too much further. And then probably what we want to do next is look inside, the response and convert that response into a data structure so that we can work with it into a data structure. So you'll notice that I don't know anything about what we're doing at the moment. I'm just simply listing out the thought process that I would go through from all the steps I'll need to do to achieve the solution. So let's say that we've retrieved the URL and we've converted that response to a data structure that we can work with. The next thing would be to parse the data structure, obviously. So to go over that and retrieve the interesting data out of the response. Uh, a lot of these SaaS providers have a lot of other metadata that they provide from their API. So sometimes we don't want to grab all of it, so we want to retrieve the interesting data out of it. So obviously that would be at minimum. At minimum, we'd want obviously the IP addresses, public IP addresses. And given that we're going to probably create firewall rules, we probably want to ideally add a description of what that IP address range is for. So let's do add a description. Okay, so we work out where the URL is, we retrieve the URL, we pass the data structure, and then the next bit is obviously to output that data structure to a file format. So output data structure to a file format. All right. To keep things simple, we'll just go to a simple text file. But what we will impose is that we should be able to potentially be able to save outputs to other formats. Potentially CSV as an example. So we've now documented our workflow or what it is that we want to achieve. And you'll probably notice here that some of these are going to make up our Python functions going forward. So what we're going to do now is create a Python virtual environment for us to write our solution in. So Python virtual environments are a really good way of, I guess, containerizing all your development work and making sure that when you install Python modules, you don't affect other projects or solutions within the same machine you're using. So all I've done here is create a virtual environment using whatever version of Python 3 I have on my machine. And the next step would be to activate that virtual environment. Okay, and if I just do Python, I'm using Python 3.8 here. Okay, so now we've created our virtual environment. The next step is I'd really recommend using a requirements.txt file to capture all your requirements as you develop your solution. This just really helps when you have to move this solution to its final place, and it just makes it a lot easier for everything to work for everyone else. So in here, I just have a standard set of requirements that I use across the board. So let's just go ahead and install those. So I use Black for code formatting, Pylama for linting or code audits, and Bandit as a security tool. So let's just go ahead and let that install. Okay, so whilst that's installing, let's set up a structure. So we've got this top level folder called API Parser Demo. So even though we're only addressing one solution today, it probably makes sense to make a new subfolder called AWS. We'll put our code inside there, and that way, if we had Azure, GCP, Salesforce, whatever else, we could have our multiple folders under here. Okay, while that's installing, okay, that's done now. Let's just upgrade pip while we're at it. Pip install upgrade pip. Okay. Let's go back to our workflow and let's start to work through what we've decided we're going to do. So first thing we need to do is find out where the AWS public ranges are situated. So I'm literally going to open Google and type in AWS public IP address ranges. Let's click on this link. Okay, so let's just have a quick read through this. So AWS publishes its current public IP address ranges in JSON format. To view the current ranges, download the JSON file. Okay, so here is a link to the JSON file. And what we can do is just have a look through the documentation. So they provide the sample syntax of what should be provided in the IP ranges.json file. And they describe all these different elements within inside the JSON format. So it's telling us whether it's strings, arrays, etc. Okay, and then there's some sample code for PowerShell, Linux, Python. So we won't read too much of that. First thing we'll do is we'll open this up in a new tab, and Firefox has this really good feature where if it can detect the file type and then show you, show it in a nicely formatted manner. If I click on raw data, as you can see, that experience is different to the JSON format. So in here we have what seems to be prefixes key, and under there looks to be all the different values. So let's just open a couple of random ones. Okay, we have an IP prefix, region, service, and network border group, which is shown here. And we also have IPv6 prefixes. For today's demo, we'll just go over IPv4 prefixes, I think, just to keep things nice and tight, and then we will develop it in such a way that you could potentially look at doing IPv6 yourself. Okay, so it looks like we've found our website. It's telling us in a JSON file format, so let's grab the URL and let's go over to here and let's document the URL. And I think that's all that we're going to need for that to start with. So what we'll do now is let's just start developing the solution. So I'm just going to create a new file under this AWS folder, and I'm going to call it public IP parser. Okay, so I'm literally going to do this from start to finish, and just so you can see sort of how I go about developing things. First things first, just a quick disclaimer. The solutions that I develop here, or the techniques that I develop here, aren't the right way to do them. They're just a way to do them. There are many different ways to solve the same problem using Python or any programming language for that matter. So I wouldn't get too caught up in the way that I do it. This video is more to show how I go about developing a solution. So generally the first thing I do is just provide a docstring of what this file is for. So this script is used to pass the AWS public IP ranges into, say, various file formats. And what I like to do is just embed the documentation here so that the next person that comes along can read this document and actually understand how this solution was developed. So we'll do that first. Okay, so if we go, I'm just going to change this to split screen now so we can look at the workflow at the same time as we're developing the solution, just so we can tick things off. So if we have a look on the right hand side here, we've found the URL and we've worked out where the public IP ranges are situated. So let's just mark this off as complete. Okay. The first step we've got documented here is to retrieve the URL. So what we're going to do now is pick a Python module to retrieve a URL. The one that I'm currently using at the moment is the Python request module. It's pretty mature, it's got good documentation, so we will go ahead and use that. So the first thing we're going to do is document our modules that we're importing. So first thing is we're going to import modules, import requests. We're also going to add requests to our requirements file, as per what I said before about just keeping your documentation up to date. And the really good thing about this now is I can just pip install from the requirements file, and it will show that black has already been satisfied, Pylama has been satisfied, which you see up the top, and now it's going to go and collect request and install it. So whilst we wait for that to run, if we just have a look in here, what we can do is read through the documentation about making a request. So what we're going to do is a get request to get this JSON JSON formatted URL, and then we're going to work through it. So given that we didn't need to authenticate using our browser to get to this site, we don't have to worry about authentication. So something as simple as this should work to get the request. And what else we can do is we can go through and we can get the text out of a file, we can get the URL of, of the request that we retrieved, we can get the coding, and what we're going to use is this JSON response content. So what we're going to do is use the built-in JSON decoder to decode this JSON format. So that's going to help us when we need to transform it into a usable format. We can also do a whole bunch of other things in here. We can look for the status code. We can retrieve, the status code just like we would through a browser. And we can also do things like, I think we can look up whether a response is okay or not. Let me just go to the documentation. I think if I just type OK up here. Yep, so we could get the status code and we could do, if status code equals 200, do this. If status code equals 201, do this. Or we can use this OK functionality where basically anything less than 400 means that it's generally good. So we can use that boolean value rather than working out a status code for all the different status codes. So I think we'll look at using that one. Okay, so let's go back here and now let's just confirm that request is installed. Yep. Okay, so now we're going to start working on step 2 of our workflow. So the first thing we probably want to do is write out a function name. So let's call it retrieve URL. Obviously with functions, you can literally call them whatever you like, but try and keep them pretty logical and try and keep them meaningful and empathetic to someone who's coming along and reading your code. I mean, we could name this, def. We could name this function do stuff, and technically it'll work fine, but really, I mean, that's just not being empathetic to people that come and look at your code after you're done. So try and keep the names pretty legible. So what we're going to do is we're going to define some functions. The first one's retrieve URL, and as you see, with writing out our pseudocode, it helps us actually name functions as well. So obviously we're going to want to pass a URL variable into our retrieve URL. Obviously we're only using one URL for the case of this example, but we should make our code scalable wherever possible. So let's start out by documenting our function. This is a good habit to get into. Document as you go rather than at the end. It's completely fine to do either way, just the main point is to document. So retrieve the URL and pass the response for success, failure, and a structured data output. Next thing to do, another good habit to get into is to actually document your variables that you're asking people to provide or not provide into the function. So we always want to do this. So in here, we're just going to document the URL parameter, and we're going to document it. Obviously, this is pretty obvious, but just get into this habit and stick to this habit, and you'll make your life easier. So what we're going to do is just provide an example. Obviously, this is pretty obvious, but again, if we don't provide an example, then people might do different things or weird things. So in here, I'm going to put the fully qualified URL. So if someone was to provide, say, google.com.au, this is saying that this may or may not work. The type, so the parameter type is a string. Okay, so now we can actually start working on our code. Now, before I get too much further, I've already done something very similar to this before in one of my other solutions. So instead of reinventing the wheel, we're just going to go and grab some sample code and use that. So no point rewriting things from scratch when we've already got something similar. So I'm just going into Net API Tools, which is a tool that I wrote a little while back, and I'm just going to click on the raw, and there's a try except block in here for accessing a URL. So I'm just going to grab that out and paste that here and adjust this to fit my needs. So we won't need any of this. So I'm just gonna delete some things out that we don't need. So first thing we're gonna have is a response. So I'm just gonna name it resp. So get the URL, and the URL will just be the URL, which is passed in at the top of the function. And Python request has a way to catch exceptions. So what we're going to do is we're going to, if there's a 403 exception or there's another exception, we can actually catch those exceptions and print them out to the screen. So I'll just use simple printing throughout this entire solution. And what we'll do is we'll just print those to the screen. So what we're going to also have to do is import the request exceptions up the top here. And basically what we're doing now is we're just going to use a try except block. We're going to try and get the URL. And if it fails, we'll, due to a HTTP error, we're going to print out that HTTP error. And if there's an exception, if there's any other exception, we'll print that out as well. I highly doubt that something's going to hit this exception. So I guess this is just there for if something really bad goes wrong. So let's just keep documenting this. So try except block to retrieve the URL. Okay. And now what we're going to do is, so we've got our basic function here. And what we're going to do is go down here and call the function. So what we're going to do is define our URL, which is this URL here. Oops, apologies. Define the AWS URL. Okay, and then execute the function. Okay, and what we're going to do is we're just going to print out, we're going to do a series of print functions. I'll just call them debug printouts, just so that we can see what happens. Just going to do this so we can have a look through and see what happens. Okay. Let's call our script. Okay, so we printed the response. Response is 200. Let's mess with this and put like a double S here. And now we're getting response of 403 because the URL's invalid. So that appears to be working now. What we're going to do next, though, is we're going to um, deal with this particular issue that we have, which is report successful failure. So what I'm going to do now is do another print, and I'm going to say response okay, and put a dash there, and then do resp dot okay. I'll toggle. I'll leave that one on. So now we've got a response of 200 and a response okay is true. So this is valid. If I change this to ranges with two S's now, I get response okay equals false, and you can see the response code is 400. So back to that documentation before, it's correlating up with what's written here. So I think we can just use response okay. We're not doing anything crazy like providing in credentials or anything like that. So I think that this is going to fit our solution well. What I am going to do though is just show you. Um, let's just try and break it even further and put some other junk in there. Apologies. Let's do something like 2 dot. Turn that off. Yep. So sorry, I wasn't reading these properly. But basically, it's printing out other error occurred. So, in this example, there were no connection adapters found. So it's catching that other exception. And in this one, it's saying max URLs tried, failed to establish a connection. And then obviously the code's breaking because it's trying to uh, call this variable here, which is defined here, and that doesn't work. So this seems to be working fine now. So what we're going to do at this part of the script is we're going to assign response okay to a variable, and we'll do different things based on that result because I think we're pretty happy with that. So we'll say assign response okay to a variable. Let's just call it response okay. Okay, and then let's if response, given that this is a boolean, so if response okay is true, we'll do something. Print. For now, we'll just put something in here. This is good. And then else print. This is bad. Okay, so in here, this is where we'll start to inject our logic. Obviously, if it's a failure, we can't convert the response into a data structure. If it's successful, though, we can do that. So we're just building out a little bit of shell code that we can populate with what it is that we actually need. Assess whether response is okay. All right, so let's just run this now. Okay, so we're getting response okay is true, and then we're getting this is good. So next thing we want to do is we probably want to return, we're going to want to return some things out of this function so that we can write our next logic. So down here, we're not going to pass the data structure if response is bad. We're probably going to do something else. And obviously inside the function we're gonna try and convert the data structure if the response is good. So we need a variable to work with outside the function. And so at this point, what I'm going to do is I'm going to wrap all this code underneath into another function. So this will be our main workflow. It will call this retrieve URL function, or most likely call this parse data structure and output of data structure. So what I'm going to do is just wrap all this inside a function, main workflow, and then we can just call that main function. Okay, and before we go much further, we need to document our return strings, just like our return parameters, just like we documented our um, input parameters. So I will do that now. So response, okay, type is boolean, and a true, true/false boolean to indicate whether a valid response was retrieved from the URL request. Okay, and so now what we should be able to do is we're currently just calling the function, um, and we're just calling the function here, so we can't actually work with the variable. So what we're going to do here is just arbitrarily assign it to a variable, and assign to a variable. And then what we can do over here is very similar to what we've done over here. So we're just going to build out some shell code. So we've got execute this function, and then we should be able to, this return parameter gets assigned to this variable, and then we should be able to write something very similar outside the function. So if okay, let's actually just change this. There's no reason for this to be inconsistent. So we can change it. So we've got if response okay is true, this is good, this is bad. And I'm going to put this is good in main function, and this is bad in main function. So later on, what we can do is we wouldn't bother passing the data structure or outputting the file to a format if it's bad from the start. So let's just call this code now, save it and call it. And now we're going to get response okay is true, this is good, and this is good in main function. So this is building out our shell code to handle, this bit in the logic tree. So we've done that. Let's just, again, it always pays to test as you go. So let's just invalidate our call and make sure that everything's working. Again, we've got this is bad inside main function. So we've got the shell code here, and now what we need to do. So I'm going to mark this as complete because we've done that. And next part is to convert the response into a data structure so that we can work with it. So now what we're going to do is we're going to put a debug block on, and then we're going to start to go through what's actually available to us. So we could read the Python documentation, but I'm just going to show you how to use debugging. I'm using Visual Studio Code. PyCharm has a very similar feature. What we're actually going to do is look inside the objects so that we can assess how what values are available to us. So I've just got a debug block on here, and I'm going to click Start Debugging and select Environment Python, and we'll debug this file. Apologies, it would help if I clicked on the right file. Was trying to debug my markdown file. Apologies about that. Okay, so if we just scroll back through our code, we've got this variable called response, and um, you can see in here we have, the status code, which was documented in the request module that we saw before. We have the URL, we have the text. So this is where we can look inside here and start to see everything that's on offer to us. If I hover over response OK, you'll see that that is showing as true at the moment. Um, and there's a whole bunch of other things in here. We can take cookies, we can grab the headers out, we can do a whole bunch of stuff. But what we want to do is have a look inside the text. So in here, you can't really see it that well, but basically, if I hover over this, it's basically got all the different prefixes in here. Um, but it's in not a great format for us to work with in terms of structured data because it looks like it's using new lines in here. So what we're going to want to do is go back to the documentation and use the JSON decoded, the JSON decoder and assign that to a variable. So what we're going to do in here is, so if the response is true, that's when we want to assign the output to a variable. So what we're going to do is document that. So assign JSON decoded output to a variable. And I'm going to call it output equals resp.json. So I'll just show you this so that you can have a look at it. So this is just essentially how you call it. So I'm doing the same thing. And what I'm going to do is turn off this debug statement now. And what we want to do is obviously return output as well now. And we obviously want to document that as well. Just with your doc strings, I know it's like a finicky thing, but document them in order as well. If you don't have a good reason to not be consistent, just be consistent. So the JSON decoded output from the request. I believe this is a list. If you don't know it, that's fine. Just as long as you document what it's for, we'll just put list as with a question mark. We'll come back and solve that. So what we should be able to do now, we've basically turned this into a tuple now. So this isn't going to work. This isn't going to work in the way that we hoped for it to work. So what we have to do now is change this to something more generic, say response, and then we need to retrieve the response okay result and assign to a variable. So basically the way it works is that's going to be element 0, and that's going to be element 1. So we should be able to do resp okay equals response 0. Okay, let's just run this. I'm going to stop this debugging now. We don't need it. We'll run this code. Oops. Just make sure that works. Yep, so it's still hitting this is good in main function, and I've turned that off. So now what we can do is This is to get our response back. What we also want to get is our output. So let's retrieve the output result and assign to a variable. Okay. Just what we'll do is let's just print this out as well, just for now. So output. For those who haven't used an F string, it's a really good way of formatting your printing strings. It's only available in Python 3.6 or higher, um, and it's a really good way. You'll see in a little while where we can just format our string instead of doing it the old way and print things out, concatenate our functions together. Okay, so let's just scroll back through this. So we've got a lot of entries in here. Looks like we've got IPv6 in here as well. Um, so that appears to have worked, and it's also said this is good inside main function. So so we've been able to get the response okay and the output. So that's completely fine, but what we also need to address is what happens when our response is bad. Because we're always returning something, no matter what, we're always returning this output parameter. It's actually not defined under else. So as you can imagine, um, when we go to use it outside of this function, it's going to break the code. So here it's saying, you know, basically on line 53, it's saying, you know, you're referencing this, but it's not actually defined under this else block. So we need to find a way to deal with this. So what we're going to do is we're going to assign the raw output to a variable. So we could assign the raw output to the variable, or we could do something like, you know, invalid, you know, have a static variable like this, and that will then do this, and the code will work. But that's kind of hacky. Also, the raw output has valuable data in there that we might actually be interested in that will inform the user why something's not working. So I believe it's resp.txt, but let's have a look. Content. So in here we have, you know, it will print out the text. So let's put the raw text output to a variable. Okay, and now let's run this. Let's turn off. We've got rid of the invalid string, and we'll see why this is a little bit better. So even though this is horrible to read, it does actually tell you in there access denied. So that's more. Whilst we could hard code it to invalid, that's not really great. So so yeah, let's use that. That's better than nothing, and it'll roughly tell the user what's wrong. Let me fix this back up again. Also back to our issue before where we were trying to find the output, or what the parameter type of output is. We can do print, and then just in case the type inside, so we can just print the type of the variable to the screen. So let's just do that. I'm going to turn this off. Okay, so it's a dict when it's good. Let's see what it is when it's bad. So let me just break this URL. Okay, so it's a string when it's bad. So this isn't really great, but better to document it either way. So when URL is successful, a dictionary is returned. When URL is not successful, a string is returned. So I'm not going to document the type. I'm just going to leave this here. I mean, this isn't great, but for the purposes of what we're doing, it's documented so someone can read it and find that out. So I'll put string output here. Okay. So we've now converted the response into a data structure that we can work with. We've got two different data structure types based on the URL being successful or not. Now, for our example, no one's ever going to come in here and change the URL. So I very much doubt that we really need to worry about when the response is bad and doing a whole bunch of, you know, nice formatting around the return string. We basically just want to tell people it's broken and get them to look at it. So that's why, although it's not great returning two different parameter types, really returning two different parameter types is better than I could create a dictionary in here um, and return that, I guess. Um, Actually, you know what? We could probably do, yeah, well, I could do that, or I could just leave it. So I'll just leave it for now. Return response, okay, and output. Okay, so the next step we're going to do is we're going to pass the output. And now we know that it's a dictionary that we're expecting. So we're going to write our next function now. So we will call this pass output. And what we're going to do is feed in the output string, sorry, the output parameter. So let's just document this out. So pass the JSON output, pass the dictionary output, actually. Pass the dictionary output into a usable format so it can be saved to a file. Okay, and let's document our parameters again. So parameter is output the dictionary, the dict output, which needs to be passed. And we already know the type from before, which is a dict. So we wouldn't actually be hitting this function if the response is a failure. So it's only ever going to be dict as it gets passed into this function. And so we've documented that. Now, whenever I'm trying to pass over results, what I really like to do is document the data structure that we're going over. And the reason that we like to do that is when someone comes along, in a year's time or 3 years time or 3 weeks time, you want to let them know your intent as to what it is that you're actually passing over. So what we could do is grab all this nasty stuff out of here. But given that AWS seems to be quite good with their documentation, what we're going to do is just take this example here, and we're going to document that inside our function. So this is going to seem a little bit weird that we're doing this. Just it's just a good habit to get into, because as we go through and extract out the values of interest, the next person that comes along can really understand, what it is that we were. For example, when we try and grab this value out, they can understand that we're expecting the data structure to be like this. I mean, there's nothing stopping AWS changing this data structure, maybe changing this from prefixes to IPv4 prefixes. There's nothing stopping them doing that. So documenting what it is that we're expecting means that if or when it breaks, we are clear as to what it is that the programmer was intending to achieve. So again, we've documented that out. So what we're going to start to do now is we're going to start to build out this code. So first things first, I'm just going to change this to say something a little bit more friendly. So I'm going to say the URL response was not successful, and then on this line I'm going to put the output. Okay. So I'm just going to this is literally all we're going to do for not successful ones. So we're just going to print out not successful message and output. Okay, so that's covered that off. And what we're going to do now is we're going to build these other two pieces of logic under response OK is true. So what we're going to do here is we're going to pass this output. Okay, so just on Docstrings, this is one of the advantages here. You can hover over your function and actually read what it is that you need to pass in. So what we're going to do here is we're going to supply the output of retrieve URL as the input into parse output. So we're going to do output equals output, and now we're going to define the URL, we're going to retrieve the URL, and then we're going to take the output out of that function and then feed it into the next function. And this is the way that we chain our logic together. So execute function to parse output. Okay. So now we've got this data structure here. We can start to work with this. There's a few ways we can go about this. We can use the debugging option to validate this data structure. Given that it's already documented, what we're going to do is we're just going to try and access all these values based on what we've got documented here. I mean, it's a good way for us to test whether the documentation's up to date. So what we're going to do is retrieve series of values and just make sure that this is actually working correctly. So what we're going to do is let's grab, say, the sync token first. So I'm just going to assign that to a variable. Sync token equals so it would be output, then our key. So we're in the output dictionary, and our key would be sync token. And let's grab, say, the create date as well. Do very similar thing. So place that and call this create date. Again, we can name these things whatever we want, but just think about the person coming along next. So let's print these out. So let's say sync token is sync token, and copy that line, create date is create date. Okay, so let's print this out now. Okay, so that's the create date and the sync token. And what we're going to do, just to validate our results, we'll go over here and I'll just do a search. And as you can see here, the number that I took from our output matches here. So I think we can rely upon, we can definitely rely upon this data structure to be correct. As I mentioned before, we're just going to do an IPv4. We're going to grab out the IPv4 results. So what we're going to do now is let's assign this key, and let's grab all the values under this key and assign them to a variable, and then we're obviously going to have to iterate over all the different results. So obviously you can see over here there's 0 to 3,626 entries. So what we're going to do now is assign that to a variable. So with the variable name, we could go, I'm just going to name it something for a second and just talk about variable names. So so in this example, I'm going to split screen so we can look at multiple things in the code at the same time. So we can call this something, right? We could call this prefixes, but it's kind of confusing calling it prefixes. I imagine what's happened is AWS only ever used IPv4, and then IPv6 came along. So if we call this prefixes, we don't know what type of prefixes they are. It could be IPv4 or IPv6. So let's give it a decent name and call it IPv4 prefixes, because that's what it is. Um, so we will assign the IPv4 prefixes to a variable. Okay, and let's just print IPv4 prefixes now. Okay, so we've got quite a large list in here, but just scrolling through here, there aren't any IPv6 prefixes in there. So everything's in there now. And now what we probably need to do is to iterate over the results and grab out all the different IP prefixes. First thing, so there's a few ways that we can go about this. If we go back to our workflow, we need to pass, we need to retrieve the interesting data out of it, and grab the public IP address and grab a description. Now, if we look up here at our data, we don't really have a natural name for a description, because obviously the region isn't unique enough, and the network border group appears to not be that unique either, and the service is obviously not going to be unique, because, for example, if you were trying to use AWS S3 in East 1, there's probably more than one public IP address range in there. So what we're going to have to do is probably make our own description, but what we might do is concatenate these entries together as we go. So the first step we're going to do is um, we're going to create a dictionary. I think a dictionary would be best for this solution to add our results to. So let's create an empty dictionary to add our results to. Now, we probably want a top level key so that we can iterate over it a little bit easier. So I think we'll go with IPv4 dict, and let's go with IPv4 results. And then this is where we're going to store all these entries in. And looking through our data, we're probably going to have, if we only concatenated this and this together, it's conceivable that the same region and same network border group has the exact same subnet. So we're probably going to need a way to make names unique without overthinking the solution. Probably a few ways we can go about this is to create a counter and then iterate over the loop and add a counter to every single name. That way the names won't be unique. The counter, the names will be unique. The counter won't really mean much, but it's better than nothing. So let's create a unique counter to be added to each entry. Okay, and I don't know, let's call this the AWS counter. Start that off at 0 and we'll increment that. Um, so to the main bit, we're going to have to iterate over this IPv4 prefixes. Iterate over the IPv4 prefixes list as denoted by the square brackets, and then we're going to have to extract values out. So we're going to go, again, we could name this for Bob in IPv4 prefixes, but what does Bob mean? So we're not going to do that. Just let's call this for prefix in IPv4 prefixes. And again, we're just going to do some printouts for now so I can show you, and then we'll do the dictionary bit afterwards. So what we're going to have to do here is let's just assign a few. So IPv4 prefix equals. So remember, now we're at this level of the data structure. So if we wanted to access this value, we'd have to access this key. So it should be this. And let's just assign all the other variables for now. So let's do the same for region, and let's do the same for region and network border group and service. So let's do that. Region, network border group, and let's go service as well. Just going to change this for a second. So assign retrieve values and assign two variables. And then let's do some printouts. Okay. So let's go. I'm just doing this, so I'll do a few so you can see basically how this works. And what we're trying to do is we're just methodically working our way through the data structure and just making sure that everything is what we expect before we move uh, too too quickly. Um, so we're just going to print everything out and then make sure that that's what we're expecting. And then what we'll do is add them to the dictionary. So network border group. Okay, I'm going to turn off this now. This this variable, printing out this variable to screen, and we're just going to print out the more specific ones. So hopefully now, if we run this, apologies, sorry, what we need to do is change this over here to the to the to the item that we're iterating over. So I need to change all these. Okay, cool. So now we've got everything printed out to the screen, as you can see, in a neat format. What we also will do is increment our unique counter. So let's just do that. So it would be AWS counter. So plus equals 1, which means it's going to increment it by 1. And let's just print our counter out as well. All right, let's run that again. Apologies. Okay, cool. So our counter is printing out as well. So now what we can do is we go back to our to this. We now seem to be at the right level of the data structure, and we've got all the values that we needed assigned to variables. So now we can obviously grab the public IP address, which we can see here, which was our core issue. We've got that. And we need to add a description. So we need to work that out. And we've also worked out how to retrieve the interesting data. So we're not getting the IPv4 data. Sorry, we're not getting the IPv6 data. That's not of interest to us. So what we need to do now is work out how to make a description. So what I'm going to do is string together the region, network border group, service, and AWS counter into a description variable. Okay, so we'll call this description, and if we have a look at our data, probably what if we there's a few ways we could go about it. So the region and the network border group seem to be roughly the same, although there's probably instances where that's not the case. So what we might do is go the region, the service, the network border group, and then the counter. So let's do region plus, and let's just put a hyphen. Yeah, let's put a hyphen as our delineator between our values. And so we're going to go region and then service. Now our service seems to be in capitals, but everything else is in lowercase. So let's just change that to lowercase. Let's convert that to lowercase inside our new variable. And then let's add network border group. And then let's add another delineator. And let's add our AWS counter as well. Okay, and let's print our description. obviously you can mix this whichever way you wanted. Um, this is just a way of solving this problem. So feel free to do whatever else it is that you'd like to do. I'm just going to add a comment string here. What I might do now is just toggle off all these others because these are the ones that we're not going to use these for now. And let's run this. Apologies. Okay. Right. I need to string my integer. Okay, so now we've got an IP prefix and description. So now we've got these two things, but we still haven't written them to our dictionary that we're going to use outside this function. So what we're going to do now is um, we're essentially going to access this IP dict, and we're going to append the IPv4 prefix as the key and the description as the value inside that key. So what we're going to do now is append IPv4 prefix and description to the IPv4 dict. Okay, so if we have a look up here, this is our dictionary variable, so we'll need that. And then remember we're using this as the top level key, so we can iterate over it later. So we're going to have to go and access that key. Okay, and what we're going to use is the IPv4 prefix as the key and add the description as a value. So we can actually do this, which will add this key in, and then the value will be the description, like so. Okay, and then outside this for loop, what we'll do is we'll just to test that this works, is we will print IPv4 dictionary results, and print that out. IPv4 dict. Okay, so we'll run this. Okay, so as you can see here, we've got like keys and values here, and they've got the that unique AWS counter on there. And if I just scroll up, you'll see that it's all inside this high level key IPv4 results. So it looks like we have what we need. So what we're going to do now is we're going to return this dictionary outside this function so that we can work with that and output it to the file. So we're nearly there. Return IPv4 dict for processing. Okay, and again, probably already guessed this already, but we've got to always document at very least a comment about our return value. So let's do that. So return IPv4 dict and the type. It's obviously dictionary. Dictionary containing IPv4 prefixes and an auto generated description. So you could go a few ways here. You don't have to document an example. I'm just going to go ahead and do it. Uh, always helps to be explicit with these sorts of things. So let's just copy this. Let's copy, say, one line here. Some people probably find this a bit over the top, but it always helps being more explicit than implicit. And I think that what I might do is I'll put this on the new line so I can just de-indent this a little bit more. Okay, and I'm just going to make this something a little bit easier. So I don't know, US East, a bit shorter. I don't know, make that 11. Okay, that way someone can go through and have a look at it. Okay, so now we're at the end and we've returned our IPv4 dict. So what I'm going to do is just turn off these print statements again. And down here now, we should be able to assign IPv4 dict to a variable and then have a look at those results if everything's working. So let's call it IP dict. Let's call it IPv4 dict. Let's keep it consistent. Okay, and then let's print IPv4 dict, and that should work. Clear the screen, run that. Yep, so that works. Okay, so we've completed task 3 on the home straight now. The last bit is we've got to output our data structure to a file format. So what we're going to do now is document our final function. So let's give it a name. Let's go output results. I think that should be fine. And we will feed in the IPv4 dict. Now, there's a few ways we could go about this. We could keep this name generic. We could change this to IP dict, because maybe we might output the IP. This might be our passing output for IPv4. We might write a second one for IPv6. Strictly speaking, it doesn't really matter what we name this, or we could name this, IP dict. Let's keep it IPv4 dict because we haven't hit the use case of IPv6. But if that was the case, you probably should refactor all the names of your names of the functions and the variables in that. So you can either make it homogeneous or generic and not useful, or make the names a little bit more useful and then refactor later on. It's something that you'll need to weigh up over time, and obviously it depends on you being able to read people's minds about what they'll ask for in the future. For this example, we're only doing IPv4, so what we're going to do is just stick with IPv4 dict. Okay, so let's just document this. Output the results to a text file. All right, and we could do something like document, to do, add more output types later on, maybe. Okay, so we need to document our parameters. Okay, so param IPv4 dict a dictionary containing an IP prefix and description ready to be outputted to a file. And that type is a dict. Okay. What I'm going to do is I'm going to show you how something that I like to do, just to skip things ahead. I'm going to want to return a file name because I know that I'm going to want to use the file name outside of a function. So I'm going to document that straight off the go. What I'm going to call this is, I'll call this variable text file name, or text file name, because we potentially might want to use other file formats. So if I just went with file name, I'll have to refactor that later on. So let's build this in. So the text file, the txt file format, file name, where the data was stored. Call this string. Okay. All right. So let's assign the text file name to a variable. So I'm going to let's call this file file name prefix. I'll show you why in a second. So let's call this AWS public IP ranges. And then what we can do is do text file name, and then we can do file name prefix plus .txt. So if we end up adding CSV, we can just keep the exact same file name and then just simply change the extension on the name of the file. So assign the file name prefix to a variable. Assign the text file name by adding the txt extension. Okay, and then next what we're going to use is the with statement, which handles context managing the file. So it'll open the file and close the file and deal with all that complexity for us, rather than us opening the file and managing all that. So we'll just write out the code first. So with open, let's say text file name, and the mode, and we'll call this as, actually, sorry, we're going to call this text file, and we'll call this, sorry, my mistake, we'll call this text file name, and call this text file. So we're going to open that file name as text file, and then inside that file, let's put a header in there. So I mean, if we printed this out with no header, we wouldn't know what is what. So let's write a header, and so let's call this text file dot write, and let's go IP prefix, and let's put, I don't know, let's use a comma to separate our things, even though it's a text file. And then we'll put a new line character. Obviously, if we don't do that, it'll append. And now we need to iterate over our list and grab out all the particular values and save them into the file. So what we're going to have to do is save the results. Sorry, we're going to have to iterate over the results. Iterate over IPv4 dict and save results to the file. Okay, and so we're going to have to go over the key and value. So again, here we can do for key value in IPv4 dict, but again, like let's name our things something meaningful because it's easier for people to work with. So recall over here, if we just go back to our function here, we've got a top level key. So we need to refer to that when we're going over our iteration. So we want to, for IP and description in IPv4 results dot items, and then what we want to do is format our string line first and then write it. So format our string, format our output line, separated by, let's use commas as well. So it would be output line equals, obviously here we've got our IP prefix first, so that would have to go first, then plus a comma, and then plus description, description, and then we don't want to put a comma on the end of this line, but we definitely want to put a new line. If we don't put a new line, it'll all end up on one line. And then we want to write our output line like so. Write output line to file. So let me just document this. Open a text file and save the contents of the IPv4 dict to a file. Okay, so hopefully we should end up with a text file called AWS public IP ranges _.txt, and hopefully we should end up with all our data under there. Okay, and finally we want to return the file name. Okay, so return text file name. Okay, and so we can then use that outside this function to do other things. So what we're going to do now, I'll just put it up on this screen. We're going to output our results. So we'll go down into our main workflow and we'll get rid of this print statement and say execute function to output results to text to file. So we'd have to call, I'm gonna go file, text file name equals output results and IPv4 dict equals IPv4 dict. And then I'm going to say, because I've assigned the text file name here to return, I should be able to print out something like outputs were saved at, and then provide the file name. Okay, so let's run this. Okay, I didn't put a full colon here, so that's why that didn't work. And I probably should have picked that up because that was complaining before, but let's run this again. Okay, so uh, you see here, I've actually printed out the file name. So this helps when maybe you need to send this message in a text file or an email application. And if we go over here, this will be the test. Okay, great. So we've got our IP prefix and our description, and it's all comma separated. So if we go over here, we've completed this, and at this stage we could say that this is completed. What I'm going to do now is just a couple of optimisations of the output of the data structure, and then we'll wrap things up. So next thing is over here we've done the text format. So let's deal with adding CSV functionality to this. So first thing I'm going to do is I'll change this to a tab, and over here change that to a tab. And let's just run the AWS public IP ranges again. Okay, so now I've tab separated this text file, so you can see you can change it whatever way you want. What we're going to do now is we're going to provide some boolean values at the top of a function, and then we're going to use those to call text or CSV as needed. So let's do text equals false. I'll come back and explain this in a sec. Text equals false and CSV equals false. Okay, so by default, actually let's change text equals true, because by default we want text to be outputted. So this is just a basic example of using Boolean flags inside your function, so to expose more granular functionality outside the function. So what we're going to do is just document these quickly. So param text flag to indicate whether you would like the results outputted to a text file, and default equals true, and type text equals Boolean. Copy all this, and actually, you know what? Let's add one more. Let's add file name prefix as well. So we can so a user can maybe choose a different file name if they want. And what we're going to do is give that default value, which is this value here. And then we can document that as well. So again, let's keep them in order. So I'll need to add it up here. File name. Obviously, you can do whatever your imagination wants or whatever your requirements are for this type of work. So we're just gonna I'm just showing you a few ways to add a little bit more functionality to your function um, to expose more conditional logic to the user. So a a a name which you would like to prefix the file with. So let's just give an example. Let's just say file name prefix equals Bob. Output files would be bob.txt. The reason I'm using Bob here is to focus in on what are the parts that are actually valuable, which is what happens afterwards. And, as in the name gets appended with CSV and text. And that type is a string as well. Okay, so now what we're going to do is we'll obviously return a CSV file name, and let's return a CSV file name as well. Okay. All right, so first thing we need to do is get rid of this now because we're passing that in at the top of the function. And the first thing we need to do is deal with these boolean um, boolean switches. So we're going to do. We've obviously written our text function, so we can do um, if text is. You can do if text, but I'm just going to do if text is true, and then I can essentially indent all this. Actually, you know what? Let's just leave that D indented, and I'll just come back and deal with that. And then um, we don't need to do anything if text is false. Actually, we'll need to do an arbitrary file name, so I'll just call it blank file.txt. Okay, and now what we can do is essentially follow the same format with CSV. So I'm just going to change all these so that they match a loose naming convention. So I'm just changing basically everything that's text to CSV. CSV file, CSV file, and obviously a CSV file has comma separation, so need to change these from tabs to commas. Okay, and we also need to return a it's going to return a blank string. Return blank string if set to false. And I could probably document that on this line. Do that here as well. Okay, just document this. So process the results to a text file. So basically what we're doing now is we're providing functionality for people to supply their own file name, to request whether they want it in CSV or text format or both, and um, then what's happening here? I'll just run this code in a second so that they can provide, whether they want CSV or text and what they want the file name to be. And if they don't supply a file name, it should be handled by default. So what we're going to have to do now, I'm just going to do a shortcut. So we'll run it with the defaults. Okay, let's try and run this now. Okay, so if we just go back up, by default, I'll just close these out so we don't need all these now. So by default, I basically called the function with its default variables. So if we have a look, default variables are it'll supply its own file name prefix, it's going to output the text, and it's not going to output the CSV. So as you can see down here, the outputs were saved at, and there's no entry. So what we can do now is provide a file name prefix and call that whatever we want. So let's say updated AWS data. And just to be explicit, what we'll do is we'll set all these to what we actually want. So I'm going to set this to text equals true and CSV equals true. Okay, let me have a look at what's going on here. Apologies, I changed the wrong variable name. Okay, so now if I refresh this folder, we have an AWS updated data CSV and we have an AWS updated AWS data.txt file. So people can supply their own file name prefix, set it whether they want it text or true or false, and as a result of that, they can get the results as they need it. So finally, let's just do a few other things which I like to do with my project. As highlighted at the start, let's reformat our code using black so that we adhere to a uniform style format. So let's do that, and then let's use Pylama as well, which is a code linter and an auditing tool, and that will tell us if there's any issues with our code that we've written. So I'm just going to Pylama that particular file, and it's saying this line 159 is too long. So let's have a look at line 159. So it's not happy with the length of this line. So we can shorten this line up a little bit, and it's probably going to complain again. But let's have a look. Okay, one more thing is we can run bandit on our file and just make sure that there's no issues in terms of security issues. So I don't have any security issues with the code that I've written. So one last thing before we wrap things up. Obviously, we can go through and toggle off all the print statements. What I'll do is I'll just commit this up to GitHub and people can go through it. I'll go through and clean it up a little bit. So let's just adjust this. Response was successful, and let's say commencing parsing. I'll run that again. Okay, one more thing that we didn't check, which I will just check before I wrap things up, is we wrote our else statement and then we went through and parsed the output and the text and the file name. So if we split our screen and we go back to the workflow, we've completed this as well. So what we should do before we wrap things up is just break that URL again and make sure that we don't, fall into this logic. And for example, we don't want to pass the output when we know that the response is broken. So let's just break our URL and run our code. And as you can see here, it's said the URL response was not successful, and then is printed out the error. So it hasn't even bothered to pass the output. So thank you for joining me today. It's been a really long video. Hopefully you've got value out of watching me develop a solution from scratch. As I mentioned at the start of the video, this is just an example of how to achieve an outcome. The intent of the video was more to show you how I go about breaking down a solution, how I build a solution out, how I iterate over things, in an incremental manner to get to the end result. Obviously, this solution can be iterated over and optimized further. Feel free to do so on your own or to provide suggestions. Thank you very much for watching this video, and I really appreciate any feedback that you have in terms of whether you found this helpful or not, and have a great day.